Welcome to Transforming Work with Sophie Wade, exploring the future of work. Find out what's going on, disruptions, evolutions, opportunities, challenges, and interventions in our multi-generational distributed organizations. With a new tech and talent focus, discover what you need to know to stay upskilled and relevant and ensure your business keeps its competitive edge. Sophie investigates the promise and reality of the future of work now and as we look ahead. She interviews people who are changing work experiences and practices and shares how we can each transition smoothly and successfully to effective and more productive new ways of working.
Hi. In this episode, we take an AI-powered leap into the future to consider our brains, our lives, our work, and our world augmented by AI. What expansive possibilities can we imagine enabled by emerging AI capabilities that actually mimic the human nervous system rather than a neural network? For example, personalized education. What if we can search and synthesize not just the entire internet's volume of words, but also observe, explore, and understand 3D digitally twinned space that evolves in real time? What more will we be able to run, review, improve, repair, monitor, and safeguard? What more will we be able to accomplish when AI can intelligently operate systems for us? I am thrilled to be speaking with Dan Mapes, founder and president of Verses.AI, an advanced artificial general intelligence and spatial web company. He is also a founder and director of the Spatial Web Foundation, enabling the 3D internet. These two projects deliver globally networked artificial general intelligence. Dan co-authored the best-selling book, The Spatial Web, and is often a keynote speaker on the impact of AI, XR, and blockchains on business and society. Hi, Dan. How are you?
Sophie, so good to see you. Everything's great here in Los Angeles, and looking forward to our conversation.
We first met, it was a good 20 years ago, more than, when you were in the gaming industry, which is where you had started. But prior to that, was it an interest in gaming that got you into this whole interactive virtual reality space?
Yeah. I had gotten a fellowship to do my PhD at Berkeley in artificial intelligence, and studying with Wes Churchman and Eric Jansch. And it became really clear that there was an ultimate teleological goal state that humanity was heading toward that it didn't know about yet. And that was the ultimate piece of software was software that would rewrite itself. So no humans would ever have to write software again. The AI would just rewrite itself and evolve itself the way we evolve. And so that would be the end. That would be the last software program. And then
And you could see that then?
Oh yeah, absolutely. Yeah.
Okay.
I mean, it's
Easy. All right.
the
Okay.
HAL 9000 and the data.
Oh, okay.
They're all
Sure.
learning. They were in sci-fi, but we didn't know how to make that. But it was obvious we were
Right.
going to figure that out. So
Okay.
we figure out they're called self-evolving systems, as opposed to
Okay.
right now everybody's hearing about ChatGPT,
Mm-hmm.
but it's not a self-evolving system. It's a machine.
Right.
OpenAI had to spend $200 million and 2 years building ChatGPT-2. Then we could use it. Then they had to spend 2 years and $200 million building ChatGPT. Then we could use it. So it's no different than waiting for the next iPhone. So those
Okay.
are still in the machine age.
Right.
But what we really want is something the way like humans are. We don't have to go into a industrial setting and get a new download for a better brain. We just learn every day, and so we
Right.
have an interior model of reality that we're evolving and understanding. And so a baby has a small model, and a child has a larger model, and an adult has a very sophisticated adult that travels the world has a very large model. So then you can make better decisions, and the more educated you are, that kind of thing. So the same thing with software. Obviously, if you can have software that learns, then it could correct its mistakes and learn from them and evolve and grow. And then it would then race ahead and become super intelligent. And so that's been the dream of AI for a long time. People thought it wasn't possible, and others did. And I just had that in my mind. Okay, that's the end goal of the software. What's the end goal of the interface? Because we interface to a program with
Oh,
Microsoft Word. You don't really
right,
see the code that's doing it. You see a really nice sheet of paper, and you type on a typewriter, and it looks kind of like typing on a sheet of paper, but there's no paper there. It's
right.
just ones and zeros that make a design that looks like a paper or a spreadsheet. Um, and so user interface design is an important part of using a program. What would be the
Hmm.
ultimate interface? Well, it would be binocular vision, because biologically we use depth perception. And so
Yep.
it'd be a three-dimensional environment in which the AI and the human would interact. And
Okay.
we would have augmented or virtual reality glasses, and the AI could see the world that we're in through cameras, and then we would have a shared kind of data space that humans and AIs could work in together. And so I just had that in the back of my mind. And so when I left Berkeley, I set up a lab called the VR AI Lab. VR AI for, vrai. It all means vrai in French, as you know. So there's a nice little play.
Yeah.
So I ran that lab with the idea in mind that we would do R&D and work with organizations, government organizations, and corporations to solve really intractable technical computer problems, with the goal in mind, with the end state in mind of where we are now. Versus.
Okay.
So Versus is the first self-evolving AI, and the way you interact with it is through VR and AR. And so I realized that I never deviated from the original vision.
Gaming was pushing the frontier of this type of interface
Oh,
and also the back end as well, in terms of trying to create those dimensional spaces and pushing the software capabilities that you believed was going to get us to where we are now.
well, here's the really exciting thing. I mean, John von Neumann, we use the von Neumann architecture in all of our computers right now until we get to quantum computers, was really one of the really key developers of game theory. So, game theory is a general area of artificial intelligence and mathematics
Right.
that transcends entertainment games. So, it looks at life, at the choices we're making on what we buy, where we live, who we marry, where we travel, cars we
Right.
drive. These things are game theory decisions we're making. They're We don't know that we're doing that. But we're doing mathematical calculations to help
Right.
us survive in a complex world. And so, game theory is a general area. So, what is a computer
Mm,
that kids are playing, like World of Warcraft or
right.
Fortnite or any of these things? Well, they're game theory applications. And so, how are they working? Well, it's a big virtual world, and it has AI in it because you're playing AI characters. Well, it was a great practice space and development environment. And but in it, then we started developing new databases that could handle game objects, and those databases became the database for the Human Genome Project. Uh,
Mm,
Network
okay.
our games. So, then we were the best networking people to move images over networks. So then we did the first summit meeting for the United Nations with Nelson Mandela and Shimon Peres, and I mean, on and on and on. So using games as a foundation space, and also
Right.
games, watch them. You look at games from like 1998, like we worked on Tony Hawk Pro Skater. We were the first people to make a digital human. Now everybody's talking about digital humans. We were doing digital humans back in 1998. We did Tony Hawk Pro
I
Skater.
remember that. I do.
That was the number one game in the world at the time, and Tony Hawk Pro Skater. Then you watch them, how they're evolving, and the games today are becoming almost photorealistic,
Mm,
from kind
yep.
of very almost cartoony, and then we were
Yep.
able to use lasers and things to get more accurate faces and things like that for the characters. But now, I mean, you can almost, if you look at Ready Player One, the film that Spielberg worked in. I mean, all the special effects, even in Avatar and everything. I mean, you can see computer effects. They fool the eye now. You're almost in a photorealistic world. So now we've really got everything we always wanted. We've really got this breakthrough in AI that we've developed.
how did you get to that breakthrough? Because your approach to AI with this biological design and using what I've been reading as the free energy principle. So what difference is the biological design? It makes sense to me in terms of really trying to mirror how we think rather than how machines think. But I'd love you to explain it.
Yeah, so the only way we could get at something that mimicked our intelligence was by playing around with this machine and giving it more and more data. It's called neural nets. And
Okay.
so that's kind of the world of for the last 20 years or 30 years of building neural nets bigger and bigger and bigger and using this idea called back propagation to learn and correct. But it's a machine. So it kind of is
Yep.
like having if you were a girl, a 5-year-old girl, and you had a little doll that was programmed to talk to you. Would you like some tea and things like that? As a little girl, you might even kind of project onto the doll that it's alive.
Right.
That's open AI.
Yeah.
That's the level of AI we have now. It fools you. It kind of seems intelligent, but it's not. It's a machine. So what makes us so interesting is we have something called an action perception modeling cycle. So we aren't a machine. We're a living being, and we can see the world. So then we're building. When I close my eyes, I can still see what I just looked at. So we are building
Hmm.
interior models. OpenAI doesn't have an interior model. It's simply got 900 billion words in it, and you ask it, tell me a story about the history of Paris, and it will write you a beautiful 40-page document. And because
Right.
it just looks into its 900 billion words that it's scraped off the internet and puts them together in some kind of a believable story. And it doesn't know what it's talking about because it doesn't know what Paris is. It doesn't know anything. It just put
Right.
it together mathematically. But we don't do that. We actually can. We have nuance. We can look around us. A baby, even as it crawls around the house, it can map the whole house. So if it's in its room and it hears the mother in the kitchen washing the dishes or something, it can see her in the kitchen in its mind. It can crawl out there to her and tell her it's hungry or whatever. And so we take that way up to larger scales. People like you and I travel the world and deal with complex models, not just of the physical world, but of the psychological world and of the
Hmm.
political world and all these things and how to navigate through all that. Well, we're learning every day. Even this conversation, we'll learn something from each other. It's one of the reasons we're friends. We've always enjoyed our conversations when we talk. So we have the ability then to see a world, and the world's moving and changing. So we're updating our model in real time. And that could be a world model, even. And then we can take action. We can walk, we can pick up, we can talk, we can do various things. And so we can act on the model. And then as we change the world, we're updating the model. And,
Right.
it's a co evolutionary process, just like we
Right.
are. So working with Dr. Carl Friston at University College London and his researchers and our researchers, we were able to rebuild the action perception cycle that humans do. Only this time, the perceptions aren't the eyes and ears and touch and things like that. They're the entire internet. There's 150 billion IoT devices, cameras, and sensors plugged into the internet. So now
Hmm.
the AI can see like the city through that and update the city model. So we want to get a
Hmm.
city, smart city New York, smart city LA. Well, you got to be able to see the city in real time and be adjusting traffic patterns and electrical grid issues and everything. Well, you can't do it with an open AI model. You see what I mean? So
Right.
what we
Yep.
realize is there's two classes of AI now. There's classes of content creation, which is what OpenAI does. Uh,
Hmm.
tell me the story of the history of Paris, whatever. Really great for doing marketing, and these neural nets were designed for natural language speaking and for translation between languages. That's what they were originally
Hmm.
developed for, and these LLMs, they're called large language models, and now we're making them trying to make them do other things. But the problem is they've got about an error rate of somewhere between 10 and 30%. and we don't know and they don't know what the error is. Well, then you
Yep.
can't use it for mission critical things like medicine or running a city or anything like that. And so, we can kind of break the world up into the world of content creation, marketing, advertising, things like that, and operations. So,
Right.
what we really want AI for is kind of to replicate the nervous system we have in our body. So
Mm.
while I'm talking to you, my autonomic nervous system is running 90% of my bodily actions, heartbeats and food
Yep.
digestion and all that. And the only thing I really control, and I don't even actively, consciously control it usually, is breathing and a few other things. But most of the interior operations are running on a big network, and with
Right.
an AI that's running it to keep me at 98.6 homeostasis, and it's
Right.
making little adjustments. And if I have to climb some stairs, I don't have to count the number of stairs and then run the mathematics and see how I should make my heart beat 20% fast. No, as I go
Right.
up, it says you need more oxygen, heart beats a little more, breathe a little heavier. And so the AI is all running that.
Mm.
That's what we want for the.
Yep.
So that's what we just created. We created the autonomic nervous system for the planet. So it's the only way we're going to be able to control our climate problems, build our smart cities,
Mm.
the income inequality issues and food distribution and blah, blah, blah. So we now are on the cusp of a new civilization that can do things we just couldn't do during the industrial age. So it looks like we're at another one of those inflection points where we were in the past, where we left the ag age and entered the industrial age. Now we're leaving the
Yeah.
industrial age and entering a intelligent network, globally networked age. So that's really kind of a quick look at the difference of what we're doing, and we're the only company in the world doing this because this is this new AI that nobody even knows about. But Dr. Carl Friston's the number one cited neuroscientist in the world. So he's highly respected worldwide, and he and his team are. He's my chief scientist of the company, and so his whole team is our AI department. So we're the only company in the world bringing this new type of AI to the world right now.
It's mind blowing, Dan. You've said that it's going to be coming out in January. Is that correct? January 2024?
Yeah, we're launching it.
Something like that.
We've been building systems for the last 3 years. We one project we just to give you what I was talking about, operations versus content creation. European Union was very concerned with drones. Uh,
Mm-hmm.
we're going to have a lot of drones in the sky. There's going to be FedEx drones. There's going to be Amazon drones. There's going to be police drones. There's going to be
Yeah.
individual photography drones. I mean, and guess what's going to happen? They're going to run into each other. And they're going
Sure.
to fall on people and cause fires and deaths and
Mm-hmm.
all kinds of stuff. So with airplanes, we have air traffic controllers. So we
Right.
see all the planes and we're saying, you fly at, at 30,000 feet, you fly at 25,000 feet, change your heading. They're talking to the pilots. Well, you can't do that with 1,000 drones in the sky. So
Right.
the EU put out a call for papers, proposals, an RFP back in 2018, and said, "Does
Help.
how we're going to deal with the drones?" And
Right.
terrorist drones, by the way, too. I mean, so how
Yeah.
are we going to deal with this? Anybody got any ideas? So 85 European companies put in proposals to the EU. We're also a European company. We're an American
Mm-hmm.
entity. We have a European headquarters in Holland. And
Mm-hmm.
so we were one of the 85 companies to put our little proposal in. Hey, here's the way we would do it with this new action perception system, with this
Yep.
advanced AI, and treating everything as like a giant hologram. Then we can register every drone, just like every car has a license plate. Every drone's registered. And then the AIs tell them how high to fly and where they can fly. And we can build drone highways in the sky. And
In real time, it's understanding exactly where the drones are and then can monitor them and tell them where to go.
yep, and it can set a flight path for a drone, just like air traffic control does for a plane. Only the AI is doing it for 1,000 drones simultaneously. No human could ever handle that. Even if they could. I mean,
Right. So you don't even have to set up lanes because it can do it dynamically in real time.
Up lanes, but you don't even need to, right? And so you can tell the
Right.
drones don't fly near the airport, don't fly over a school. You can't carry flammable material. You can't carry you drone are only authorized to carry things up to 10 kilos, or all kinds of
Right.
right. And so we won, and like everybody said, it was all Siemens and all the big European companies. And who's this little company Versus? So we just completed a 3-year project in Europe with that, and now that's being commercialized. So we've been doing projects with large
Okay.
corporations in logistics and in drone traffic and automated drones and data science. The AI can read data. Now, if you have a large corporation, they might have data in 100 different silos because they've acquired other companies, and they don't talk to each other. And
Okay.
so they're throwing everything into these data lakes like Snowflake and whatever, and hoping someday to be able to. It's like unrefined oil, and so, our AIs have a language, which is like a universal language of AI now, and so we can translate all these different things into this new universal language. So then the AI can then build models that use all the 100 sources and then come up with better solutions and answers than before. So
is there a simple way to understand how it actually creates that interoperability or translates all this language?
yeah, I think just if you use human languages as an example, imagine if
Yeah.
you had acquired 10 companies, one in China, one in Czechoslovakia,
Right.
one in whatever, and somehow you had a universal translator to translate everything they're writing to each other into English,
Yeah.
so that everybody has an English core, even though all their native things are done in their native language. So we have a meta language that it's called
Okay.
Space Modeling Language, and so that language then becomes a language that all the AIs can
Right.
talk with, and so whatever they're in, it knows how to translate from that into the HSML.
Wow. Very powerful. What are the particular sectors that you see the most immediate and most powerful potential uses and applications? I know you have mentioned climate change to me, being able to model a digital copy of our world, to also copy it in real time. Those type of nonprofit, globally important projects, but also from an enterprise perspective, what are you anticipating as being the most immediate needs and opportunities?
No, that's the key question, and of course, it's almost like when we invented electricity. Like, okay, what's it good for? Well, you can do
Right.
lighting, and then finally you do everything with it. The whole world's running. You know, so the way we structured this thing is very much like the World Wide Web or like Apple's App Store. So when the World Wide Web began, there was one website that Tim built, and then there were 10, and now there's there's 2 billion websites and 12 billion web pages. I mean, it's
Right.
incredible. And how did that happen? Is because there's no central authority saying, Sophie, would you build this? Or Dan, would
Hmm.
you build that? We choose what we want to build from our
Right.
domain. And nobody told Jeff to build Amazon. He just saw an opportunity and built it. And same way with Facebook and whatever. So what we did is and the same with the App Store now. There's 5 million apps in the world. Well, what are they for? Everything from finance to gaming to you name it, right? Psychology,
Right.
whatever. And so what we're doing is we're flipping it over now and giving this AI to the
Hmm.
entire planet. So people that have domain expertise in climate issues will use it.
Hmm.
People that have domain expertise in logistics and supply chain management will use it. People that
Hmm.
have specialties in city management will use it. I mean, it's really.
Right.
But what's cool is because they're running on a web protocol. So the World Wide Web is great because you build a website and I build a website and they can talk to each other. We can hyperlink
Right.
them because they're running on HTTP. Well, we built the hyperspace transaction protocol, HSTP, so that all of these AI apps also talk to each other. And
Right.
they're all learning by themselves, and they're all learning from each other. So you get this co-evolutionary global brain where people that you don't even know in Kenya are building a thing for education educating school children in Kenya with AI, and suddenly people can use it all over the world. It's like an app in the App Store. And so it's really exciting that way. We don't limit it that way. We're not the bottleneck. We're not limiting it.
Right.
Come
Okay.
to us to build something. We give
Right.
you tools, and so instead of really, if you look at OpenAI and Bard and these other LLMs and neural nets, they're a giant machine.
Mm-hmm.
$200 million in a couple of years to build this giant machine, and then we get to ask the giant machine questions. And one company built the giant machine. No. That's not how the web works. Millions of people built websites all over the world, and they all talk to each other. And millions of people built apps all over the world. They all interact. So we said no. That's the proper model. We're not going to build the giant AI. That creates too many
Right.
problems. Have a bad AI. No, we're going to allow everybody to build their own small AIs. If they're a nutritional
Mm-hmm.
expert, if they're an educator on French history, whatever. These are all great applications for artificial intelligent learning environments or whatever. Well, then
Mm-hmm.
rock and
Yeah.
roll. And together they kind of create what we call collective intelligence. So our whole approach to neuronal computing, you might call it, it's not neuromorphic even, it's becoming direct. These are literally almost like neurons. Really mimics collective intelligence of humanity. People are publishing papers every day as scientists, and you can read the Nature magazine and all the breakthroughs that are happening in medicine and science and whatever. So our collective intelligence is rising all the time, and we use traditional media as a way to communicate what we're doing. But now we'll actually have AI so that the collective intelligence is evolving in real time, moment by moment, as the breakthroughs are happening. And the AIs are partnering with the researchers to be able to do things that the researcher themselves maybe couldn't do before. So it's a really
Right.
exciting moment as we step into this new game.
And how does the spatial web relate to all of this?
Yeah. So if we look at the history of the internet, there have been two big protocols so far. So the short answer is we always wanted to build the spatial web. The web we have is the spatial web, but the bandwidth in 1995 was so slow, all you could deal with were pages. And
Right.
so the original internet began back in 1970 with a protocol called TCP/IP. What did it do? Oh, for the first time, it connected computers from different companies together on a network with no central coordinating computer. In the past, in the 60s, if I wanted to join a network, I had to call IBM and say, hey, I'd like to join the Sabre network. And they go,
Okay.
great, pay us this amount of money, buy one of our gear, then pay us
Right.
every month. A lot of friction.
Yeah.
Um, and if this mainframe went down, and they crashed a lot in those days, the whole network crashed, and somebody got it
Okay.
back up and running again. And so, I'm sorry, the computer's down. You call the bank, you call whatever. And so,
Right.
um, so when we went to the web, then there was no central computer. Your computer could crash; it wouldn't bring down the whole network. And
Mm.
it's called decentralization.
Okay.
So that it's really the theme of our era. And so
Mm.
when you decentralize, then you don't have a central friction point. Anybody
Right.
can add a computer to the network at any time. It just
Hmm.
needs an IP address. So when you buy a laptop, it already has an IP address in it. When you buy a smartphone, it already has its IP address in it. What is IP address? That's the Internet Protocol address. So
Right.
every individual computer has a unique ID, and then my computer can send your computer email, as an example.
Right.
So from 1970 to 1995, the killer app was email. We could send little files between the computers. Then in the early 90s, Tim Berners-Lee goes, well, the bandwidth's getting bigger, chips are getting faster. We could do more than just send little text files to each other. We could probably send fully formatted scientific documents with photos on them and everything. And so that literally was the launch of the World Wide Web. So instead of just connecting computers together in a network,
Hmm.
we'll connect all the documents together in a network.
Right.
And that became the World Wide Web. And then he said, here's HTTP and HTML, and anybody can build a web page. You just type a Word doc and then apply this HTML code to it to tell what's bold and where's the header and how big the font is and all the rest.
Right.
And now we have the World Wide Web. And look at that. All we did was connect all the documents together. Trillions of dollars in market cap and big corporations. There were no trillion-dollar corporations in 1995, but
Right.
no one had any idea how big this thing was going to get, and it's transforming commerce and business and everything. Well, the whole era from 1970 to today is like 5% of what the spatial web is going to do, because now instead of connecting every machine to each other or every document to each other, it's going to connect every building in the world, every car, every boat, every train, every plane, everything. It's the internet of everything. Do you see what I mean? And the only reason
Right.
we didn't do that originally is the bandwidth wasn't there. But now it is with Starlink and 5G and everything else coming in. It's now possible. We're seeing Fortnite on our phones and
Hmm.
Roblox, and these are 3D environments. And so, for the first time, we can finally handle three-dimensional computer games on a network. And that's why gaming was such a good test case, because,
Yeah.
how to make, even though the game had a lot of graphics in it, we learned how to use techniques to make it run, be a lighter so it would run faster,
Hmm.
things like that. So
Right.
now we can apply all that stuff to building a virtual city. I mean, imagine a complete, we call them digital twins, a digital twin of New York City, as an example. Well, that
Hmm.
would be made up of maybe a million digital twins of restaurants and buildings and things like that. And so cities are building digital twins of the cities, and then businesses will do digital twins of themselves. And by
Hmm.
2035 or so, we'll probably have a beautiful hologram of the Earth, that everybody has access to. Kind of like Google Earth now, but really 3D. You can zoom down in, you can learn the history of an area, you can do things there. I mean, so we're stepping into something really exciting here. And so it's probably 1,000 times as big as the World Wide Web, just to give you a scope. And it has no upper ending, because, you know, the Earth is evolving and developing, and our understandings of how to manage our societies or our environment or whatever are evolving. And so this AI can help us do all those things. So it's going to be the beginning of a big adventure. The World Wide Web was a big adventure. I mean, this really transformed our societies. The spatial web is 1,000 times as impactful.
You always have an incredibly positive vision for what is possible in all its expansiveness. What is your response to people who say, well, what are your concerns about the spatial web and this new type of AI? There are many concerns about what we could do, or Machiavellian actors, what they might be doing if they're empowered with AI. What is your response in terms of what guardrails might be like? Because there's some elements in the documents and the information you shared with me about governance, which is very interesting to me, because your AI has more easily built in this idea of permissions and governance and access.
It's the next key question, obviously. Yeah, so I think there's two answers to it. One is, what have we learned so far about misuse of a global network from the World Wide Web days, and then
Mm.
what do we need to protect ourselves in the future with AI being added to it all? So if we look to the past,
Hmm.
there were three big flaws in the current World Wide Web, and we call that
Okay.
hacking, tracking, and faking. So everything's hacked.
Okay.
I mean, everything's hacked. It's like hackers can get into databases, and kid hackers break into the National Security Agency. I mean, it's like hacking is, because when the web was made, it was really made just as an open information network, where they really didn't think through these things. So there's no security layer to the original internet. TCP/IP is communication device. So it helps things move around the network, but it's open. A hacker can get in there and spoof the system and pretend it's you and tell somebody, "Oh, hi, I'm
Yeah.
Sophie, and I'm, and you don't." It's just the way the original internet was designed. It was a big enough problem to get a
Yeah.
network that was resilient, that could work globally. So they were just happy to do that, not really
Right.
no other thought than, hey, nice global communication system. And so there's, again, no identity layer in there. So I don't know that it's you. There's no location layer in there. So I don't know where this is coming from. There's no security layer in there. There's no protection from a, cybersecurity
Yep.
point of view. And so when Tim did the World Wide Web, he just did the same thing. Let's just connect all the documents. Open. It's all going to be good people, and
Right.
they're share documents. So, well, then they start, So then, because there's no identity layer into the World Wide Web, you have to log in to Facebook to tell them who you are. Well, once you log in, then
Mm.
terms and conditions. And their terms and conditions are, we're going to just scrape all your data and sell it to advertisers. And you agree to that if you want
Right.
to use Facebook, right? So we're not going to charge you to use Facebook, but our
Yep.
deal, we get to sell you to advertisers, and then you'll get special ads on your page that
Hmm.
are different than Sophie's ads or whatever. And so we got surveillance capitalism out of that, right? And so we don't like
Hmm.
Cambridge Analytica and all the other problems that came with that, and the impact on the elections and all these things. And then faking. You can't tell what's real and what's fake. Where was this really from? And so when we sat down, we said, okay, let's start with the big three problems of the current web before we build this Internet of Everything. Then we're just going to exacerbate the problem,
Yep.
So again, you just add these layers. You add security layers, you add identity layers, you add location layers. Spatial web knows exactly where everything is. And the AI kind of functions as its own immune system then. It knows where things are, or if it knows if there's a bad actor and it's getting... Right now, if somebody puts
Okay.
up a terrorist website or a child pornography website, people report it, and then the ISP takes it down. So, there is an immune
Got it.
system working super great, but it's there. And so, obviously, an immune system AI network would even be better because the AI can be tasked, like, look out for these things, highlight it if you see
Hmm.
this.
Hmm.
And so, so we built in an identity layer, so everybody has what's called self-sovereign identity. So that means that you have state, just
Okay.
like I have sovereign identity when I'm walking around New York. I don't have to log in when I walk into Tiffany's. I just walk in. I'm a human being, and
Yeah.
when I buy, then I give them my credit card. But I'm a free person, and I don't have to report who I am to everybody. And so by having
Yeah.
self-sovereign identity, that unlocks a really interesting concept called zero knowledge proofs. So a really simple example is when you go to a nightclub to go in to prove you're over 21, you give them your driver's license. And they look at it and go, okay, you're over
Hmm.
21, come on in. But they see where you live, your address, all kinds of stuff. They don't need to see all that. Well, with in
Sure.
the future, we're going to have augmented reality glasses be really common over the next few years. The bouncer at the door just has a
Hmm.
pair of glasses on, and as you're walking by, um, your identity on the blockchain has your date of birth in it. And so all the bouncer sees is a green check mark over your head. Oh yeah, you're good. You're good. You're
Oh.
doesn't know your
Okay.
name, anything about you, uh, you know. And if somebody comes with a red X, come over here. Oh, it turns out it's a visitor from Argentina. They're not in the system. She pulls out her passport. See, and then okay, you're good. Only in those cases
Okay.
don't have. And so really, we solved most of the problems from the world. You'll never get everything perfect. I mean, when they designed the car,
Yep.
then people started going through windshields and crashes. So somebody said, "Hey, seatbelts, and
Right.
airbag, or the exhaust fumes were really bad, so they developed catalytic converters. So you still have the ability to put card
Hmm.
in and things, along the way. But if you attack it at the fundamental issue, 90% of the problems go away. So
Right.
that's a real quick answer to how we've done all that. So the other good thing is you own your data in the spatial web because you have identity.
Mm.
You're not being surveilled and sold, so you can sell your data. So we built data exchange
Okay.
into the spatial web, and we'll buy the
Oh.
data from you and sell it for you to the advertisers. But you can choose. I don't want my name attached to it. Just I'm a 30-year-old woman living in New York, and I drive a Tesla. Well, Tesla would want to know that, and they'll pay
Yeah.
you to buy the data stream from your car because they want to get like a million vehicles feeding in. So it's tuning their battery designs and showing where the brakes are failing and other kinds of things. So they'll
Right.
pay
Right.
every Tesla owner for their data stream. Well, in the past,
Mm.
no way to do that, but now there is. You see what I mean? So now you're going to have not universal basic income, but really universal earned income. Because as you move, when you go shopping in Gucci, you won't be at a web page with pictures of women wearing dresses. You'll walk into the world of Gucci, a beautiful 3D world, like a big computer gaming environment. Somebody like Charlize Theron, a virtual avatar of her, is there going, Sophie, so good to see you again. Full AI, knows who you are, knows your taste, knows everything about you. You've shopped there before.
Right.
I've tried some of our newest designs. Let's go into the design room, and then you co-design the finished product with the AI, going, I'd like
Ooh.
higher. Could you do that in a bit of a paler blue? And I think I want this kind of material. And then everything just is being modified right there. So you're co-designing it if you like. The AI can
Yep.
make suggestions even as well, knowing your previous taste. And then, bing, hit the button, and then the robotic cutters. It's mass couture. You see what I mean? It's cut. You've
Yep.
taken pictures of yourself, sent them in. The AI knows exactly your body type, and so it's cut
Yep.
for you. Well, man, that's amazing. So the other thing that comes with AI is mass personalization. We pay a lot for personalization.
Mm.
Yeah, it's a big price difference between couture and pret-a-porter, but in the future, it's pret-a-porter couture. You know what I mean? It's like everything's
Yeah. Yeah. Yeah.
new. And so yeah, so I think it's real exciting what's coming here. It's a big sea change, and this is really what the internet always was. We just couldn't do it until now because we needed this 5G,
Right.
and we needed to evolve our understanding of AI and practice a little bit. Find out in some ways you don't want to commit everything until you see, like, the World Wide Web was a good 25-year experiment. How are bad actors
Right.
mis the network? Oh, who then that helps us then when we build the real thing, the final leg
Right.
of the thing. Oh, we just had a prototype here called the World Wide Web, and now we can, let's add self-sovereign identity, let's add location data, let's add cybersecurity information, the whole deal, and suddenly now you've really got the World Wide Web you always wanted. You see what I mean?
Absolutely. So, what does that mean in terms of jobs? I am focused on how the workplace is changing, how jobs are changing, the nature of work has been changing because of technology over the last 20, 30, 40 years, but in an accelerated way now, and obviously further catalyzed by the pandemic and all the technology implementations we had because of the emergency conditions. So I look at AI and anticipate that every single person's job is going to change to some degree. And we don't know to what degree each job is going to change. And we have to try and anticipate that. With the changes that you're talking about, this augments that potential for change exponentially.
Yeah, no doubt about it. I mean, the last time we went through such a major shift was when we left the farm and moved to the cities, and people had to quit being farmers. It used to take 80 people to run a farm, and once you had mechanization of the farm, it was 8 people, and
Right.
so we go like, oh my God, we're losing our jobs. No. You move to the city and learn to make tractors. And so we saw a mass movement from the farm to the city and to getting more education and becoming professionals and all kinds of things like that. And so the first stage of what's great about these things is it's an evolutionary process. So the first stage
Hmm.
is augmenting humans and doing their current job. Like the AI can help out a lot.
Hmm.
And suggest things, and they're not good enough right now to just fully automate anyway. OpenAI has an error rate of almost 20%. So even if you have it write marketing copy for your company, and you've already got marketing people that do this, but now you add AI into it, they're still going to have to proofread the thing and make sure
Yep.
that it's not saying the wrong thing and all this kind of stuff. So stage one will be augmenting current jobs with AI. And
Hmm.
then stage two, I mean, new huge businesses like robots are going to be a huge business. AI for specific industries will be huge businesses. So one of the ways you'll do is you'll get more. You'll study AI. I mean, people right now are getting paid 200,000 a year as a prompt engineer.
Yes.
AI scientists. People that have a PhD in AI are getting paid 900,000 a year. Well, then you start to realize, oh right,
Wow.
there's the money. It's over there now. It's not on the farm. It's get a job in the factory or get a job in the office. And so we're going to
Yeah.
see a movement toward a new kind of education. Our schools aren't really equipped for it, so they're going to actually be impacted almost more than the workplace because they're not
Right.
teaching.
Right.
They're teaching us how to function really well in an industrial age corporate society. But now we're moving toward big
Yeah.
nodes on the network and almost freelancers and using AI. Well, that's a different kind of education. And so the AI will even be used in education to help people understand how to use AI. So I think
Yeah.
we're just in the age of AI and virtual worlds now. Just the way we moved from the farm to the city, now we're moving from the city to the network. And so then you can live anywhere in the world you want. You don't have to be in the city. Before you had to be in the city because that's where your job was. You're somewhere within an hour of the city.
Right.
And so now you can see what's going to happen. The network is the economy. It's already starting to be that way. I mean, I don't drive to the mall to shop. I go to Amazon and hit a button and it's delivered to the house. Well, I could be in a cabin in
Yeah.
Vermont. There's no difference to
Right.
Amazon whether I'm in a cabin in Vermont or on Fifth Avenue in New York. I mean, it's just a node on the net. You see what I mean? So now humans are
Yeah.
free to move around, live in other countries, live in different countries, different parts of the year, all kinds of things like that. So we're moving toward, I think, a planetary civilization where we think at a planet level, and our climate problems are planet level, and our weapons
Hmm.
proliferation problems are planet level. So we're really dealing with planet level. So we're kind of waking up. I think we're growing up. I mean, if you look at the history of humanity, I mean, from the life in the Stone Age to life in the Ag Age to life in the Industrial Age, it's almost like children, and then grade school, and then high school. Now we're going to college, like a new level up. And
Okay.
so we're going to be way
Yeah.
smarter in 2040 than we are now 2050. I mean, if you bring anybody here from 300 or 400 years ago, they're going like, what happened to your brains? I mean, you've got like rockets to Mars, you've got robots, you've got what networks, what's all this stuff? How'd you get so smart? But actually, it's just the natural evolution of the mind developing new
Right.
things. And now we're going to accelerate that process, and we're probably going to go from 2025, where what is AI and how's it going to impact us? In 2050, it's like, oh, we know exactly how we work with AI
Hmm.
and we're starting to see the shape of the next civilization. By 2100, the transition's complete. We're in a globally networked economy, and probably along with that are governance models that are also global.
Mm. Interesting. And to go back for a second to our education, Ready Player One was a good movie, but I was really, really intrigued by the book and the idea that Wade Watts was going to school in virtual reality. And that was very powerful. There were lots of things he couldn't access from where he was in his human reality, but had a lot more access and possibilities and opportunities in virtual space. So that's very interesting for me and what that opens up and democratization of opportunities in virtual space.
Yeah, I mean, almost what we were talking about, mass couture with the design of a dress. It's cut for you. Really, what we're doing is personalization right now. So that means in education, if you want to learn French, the AI would just talk with you and figure out exactly how much French you know and realize, oh, you're pretty
Right.
good at the present tense, but you don't know the past tense really well, the verb conjugations and everything.
Okay.
And so it's just helping you. So what we have right now, we have an industrial age education with an assembly line. So everybody who's 6 years old is in the first grade. Everybody's 7 years old in the second grade. No matter what their level
Oh,
of intelligence are and what their skills are, what they really might be if you had mass personalization, maybe a 10-year-old might be 14-year-old in science and 8-year-old in and something else. And so, you bring
Oh,
everybody
amazing.
strengths and weaknesses. Some people are more interested in abstract things. Some people are more interested in music. And so we just have right now one teacher at the front of a class teaching a curriculum and 30 students. And for half the students it's too slow, they're bored. And for half the students it's too fast, they're overwhelmed. And for the small middle, it's just right. And so it's a terrible system.
Right.
And, we
Yes.
survive it. We don't thrive in it. Our high school systems globally are pretty bad. And then
Mm,
college level gets a little more focused. You can really start to choose your
yeah.
course and that kind of thing. And then if you go all the way to grad school, then you're getting almost really detailed one-on-one work with a high level expert. But
Hmm.
now reverse that all out, and from childhood up, you've got a universal tutor, that can
Right.
interact with you and figure out your strengths, your weaknesses, and help you play to your strengths, but also strengthen your weaknesses. And so we're going to
Hmm.
get more
Hmm.
humans out of it. We're really highly educated. So I think 12-year-old girls will be doing PhD level work in 2040, that kind of thing.
I guess that is how we've been advancing over the last decades and centuries.
Speeding up a little bit. We're going to get 25 years what we did in the last 100, that kind of thing.
To that exact point, thank you, Dan, for that lovely segue. The next 20 to 25 years, you gave me a great picture, which was both inspiring and somewhat daunting in terms of the next period and all the different things that we need to be dealing with and really being flexible and opening our minds to it. And you even then managed to blow my mind. You talked about a caterpillar.
Look at how far we've come. I mean, I love our Stone Age ancestors. I mean, they really survived for 200 and some thousand years, with very little, right? I mean, it was
Right.
phenomenal. All the modern civilization we have has really been since the last ice age, 12,000 years ago. Prior to that, for 200,000,
Hmm.
pretty much lived in tribes and hunted our food and made
Hmm.
tried to survive as well as we could through the winters and everything. And then
Right.
after the last ice age, we discovered agriculture, and so suddenly with agriculture we had such abundant food supplies that we could survive through the winter. People could specialize.
Hmm.
They didn't go get food every day. They could specialize in making
Right.
shoes or whatever. So we had, like a Game of Thrones. You had big cities with all kinds of the first big cities. I mean, prior to
Right.
prior to the last ice age, you couldn't have more than 100 people in your tribe because you'd overeat the area and starve. So
Oh, yeah.
tribes had to be small. So city states just emerged, in the last 10,000 years, and so we've made this journey, historically, where we've gone from these ways of working where we can't even imagine there's something better. You interview anybody in the Stone
Yeah.
Age, going like, well, yeah, well, this is it. I mean, you go hunt. We go. The men hunt the protein, and the women gather the vegetables and fruits.
Right.
We eat.
Yep.
We try and survive, and this is how it's always going to be. And then we have agriculture. Oh my God! Oh my God! Oh, we've got a global farm now. We got so much food that the
Hmm.
starts to rise, and we got kings and queens and empires and the whole deal. And again,
Yeah.
interview anybody in 1400, like this is the way it is forever. I mean, and
Yeah.
then
Yeah.
1450, the printing press gets invented, and from there, mass production begins. And by 1850, it took about 400 years, and then the industrial age was dominant over the ag age. Before that, we had some industry growing, but by 1850, it became dominant. So over the last couple hundred years
Okay.
now, in the really dominated by the industrial age, and now we've got this new AI age coming in. And so uh, I think what we're seeing is that each of these inflection points is a metamorphosis. The human being
Hmm.
is actually changing the way it lives, creates wealth, finds its food, builds things, organizes themselves into political and social organizations. I mean, on and on and on. So these inflection points are massive, and I think the most beautiful symbol we have of it in nature, because we're part of nature, is the caterpillar to the butterfly transition. So here's a caterpillar, lives its whole life, pretty much on one or two plants, just eating leaves, and then at some point it gets this crazy wild idea to build a house around itself, uh, and then it's inside the house, and then it just melts itself down into liquid, and then it reconstitutes itself, reforms itself into a form of a new animal completely. A butterfly. I mean, there's no chance you would look at a caterpillar and predict a butterfly from that. So that means it had the DNA
Right.
of the butterfly in it the whole time and was unaware of it.
Right.
We're the caterpillars now. We've got the DNA of the next civilization in us, and it's coming out. And this 25-year period here from 2025 to 2050 is our cocoon. We're in the chrysalis. We're melting down the way we've been doing things and reconstituting a more powerful, more beautiful way of living. And think about it: the caterpillar goes maybe 50 feet, 100 feet in its entire life. When it turns into a butterfly, like a monarch butterfly, it'll fly for 5,000 miles. It doesn't just fly for 5,000 miles. It flies to the same tree that its grandparent went to. It's never been there before. It knows how to fly there. I mean, come on. And so I'm saying if caterpillars have butterflies in them, what do humans have in them? What would be a butterfly civilization compared to the caterpillar civilization we're in right now? It's way beyond our science fiction. Way beyond it. If you look at Star Wars and all these sci-fi movies, they're just the industrial age in space. People are still fighting and shooting laser weapons. No, and you don't do that. As a more advanced civilization, you cooperate at a global scale. There's so much abundance in the future. I mean, a lot of the office buildings downtown are never going to be filled up again, and so we can convert them to urban gardens and with hydroponic gardening and all this kind of stuff. So growing the food organically right there in the center of the city with AI driven organic gardening. Oh my God, just an explosion of food all over the world. All the food scarcity goes away, And so we're really moving toward, I think, the next civilization. If you interviewed people from 1200 and then brought them to like today, they're going like, oh my God, you're so rich, compared to us, Well, we go out to 2100 and compare it today. We go, oh my God, you're so rich. I mean, right now we're at $90 trillion in global GDP. We'll probably be at $90 quadrillion in 2020 in 2100. I mean, 1,000 times larger. I mean, you just see these trillion-dollar corporations didn't exist. Google's $1.5 trillion. All it's doing is indexing the internet, and it's worth $1.5 trillion. There's going to be there were no trillion-dollar companies in 1995. Now there's 10 of them or 12 of them, and so we're an amazing wealth increase on the planet, and so basically the average person today, just an average working person at median level income, lives better than the King of England did 100, 200 years ago. Easy. The king would trade immediately. We've got airplanes and cars and, good men. You get sick 200 years ago, you're dead probably, That wasn't as advanced. So that means that the average person in 2100 may be wealthier than the wealthiest person is today. I mean, with CRISPR technology and things like this, we may be getting rid of all inheritable genetic diseases by 2040, 2025. Lifespans will probably go up to 120. People are living to 120, but only one in 1,000. But maybe 120 is the new 100. A lot of people live into their 90s, so we maybe expand our age up and maybe finally to 150 and things like that. So, somebody from here taking into that kind of a science fiction world would come back and go like, "You're not going to believe it. You're not going to believe it. They've got things we don't even understand. They can materialize things around them just by speaking because the AI is working at a quantum level with quantum computers, so it can actually combine the quanta into material objects. So you have a 3D printer that just prints things out of air or something. You see what I mean? So you're not trying to say
amazing.
There's miracles, and they're not miracles to the people of that time, but they'll be miracles to us. So I think that's
Right.
why the caterpillar butterfly model is such a valid model,
Hmm.
because you never predict the butterfly from the caterpillar. It's a little fat worm crawling around on a stick, and then this thing comes out, flies 5,000 miles, and has some kind
Yeah.
of intrinsic knowledge of where it's going, and so we probably have intrinsic
Yeah.
knowledge of where we're going. So we're fine. You see what I mean?
Hmm.
The DNA of what we're about to become is already within us. That's the point, you know.
Dan, I love that. I love the vision, and I love that it gives us somewhere to feel that we're going when there's going to be so many extraordinary challenges and opportunities ahead. So, last two questions. One is, what haven't I asked you that I should have done based on everything that we've been talking about, and what you know, and what might the concerns be of people who are thinking about what's ahead and what to anticipate or not?
Well, I mean, I think when we really look at what we're talking about, it's the big word behind everything that's happened on this planet for 4 billion years. And that's evolution. And so
Mm,
sometimes people ask me about the future. Do you think that evolution, which has been operating, and we have a fossil record of it in detail, for 4 billion years, from single-celled organisms to the Cambrian explosion to the wiping out of the dinosaurs and 65 million years ago to the rise of mammals and apes and humans and all this stuff? I mean, we've got a detailed vision of that. Do you think evolution has stopped? Oh, the very thing that created us, that's what is coming through our hands and creating the AI. It's just evolution in action. And so if that
right.
if the where along the line would you have stopped it? Where along the line would you have said, wait a minute, reptiles are fine, let's don't go into mammals, or mammals are fine, let's don't go into ant line, or ants
Right.
are fine. Don't split off the hominid line. You know what I mean? Like, where? No, no. Look how
Right.
smart evolution is. And so, oh, well, then
Yeah.
evolution is actually the force that's creating this new civilization and these new technologies.
Mm,
It's part of the ongoing evolution, because we've been evolving our minds, but now we're about to evolve. We're evolving our medicines. Now we're probably going to, new medical techniques. Now we're going to expand our lifespans and health spans and all these things. This is just evolution in action. And so, if you were visiting here from another planet, you would go, boy, what a planet! This is like an evolutionary petri dish. It's boom, 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 constantly
right.
pressure for
Yeah.
positive evolution, trying things and trying to find. Look, it's such a positive story. I mean, even from reptiles to mammals. I mean, the neocortex of mammals allows us to reprogram ourselves, whereas the reptiles, a turtle will lay its eggs on the beach, and the little baby turtles will crawl to the water when they hatch, and then they'll swim for 2 years in the open ocean, come back to the exact beach where they were born and lay their eggs. I mean, that is, machine intelligence maximum. But the
Yeah. It's
so
wild.
they learn and evolve, and so we've got this giant neocortex, and humans have the biggest neocortex of all the animals. But now, what we've finally done with advanced AI is we've created a digital neocortex to augment the human neocortex. So
Mm,
problems that we can't solve right now because our neocortex is so, it's big, it's bigger than any animal. But the next neocortex, the next evolution is an AI neocortex. So then it can help us. Oh, you want to solve the climate thing? Oh, well, here's how you do your incentives and disincentives properly, and here's the amount. Here's what you can do.
right.
Some trees you need to plant, where you need to plant them, and all these kinds of things. So we get a bigger brain, and that's been the evolutionary journey that we've been on. And so it's just what's happening in front of us here isn't anything to worry about or think about or anything like that. Obviously, you want to pay attention to the potential bad uses of it, but it's just part of our ongoing evolution on this planet. That is the story of this planet. It's the primary number one story of planet Earth. This is an evolutionary planet. It's constantly evolving. And how you would never have predicted us from single-celled organisms. Remember, for 3.5 billion years, we were pretty much single-celled organisms in the ocean, 3 billion years. It's only been in the last billion years we even got multicellularity, and then finally the first animals really popped during the Cambrian explosion and they filled out the niches. So I mean, you know, this is an evolutionary world. Don't be surprised about ongoing evolution.
Right.
What we create in
Right.
the butterfly civilization here will simply be one more stop along the way. Maybe we're going to be a multi-planet civilization in the future, and
Hmm?
we've
Who
already looked
knows?
at mathematics of how you fly through a black hole and things like that. Who knows? I mean, so I think we're part of an ongoing evolutionary conversation on this planet, and it's a good story.
It is a good story. And my very last question, which I always ask, is the here and now and tomorrow. For listeners, without these amazing AI powered neural networks to help, what can they be doing to start to anticipate, to project, to imagine what the possibilities could be, how to prepare and start adapting for how AI is going to augment and change their businesses going forward?
That's great. I mean, I would obviously direct everyone to our website. We've got a lot of white papers on there. It's VERSES Verses.AI.
Mm-hmm.
A lot of material there. Some of our new approaches to global AI governance, guardrails for AI, and things like that. So people that have any concerns about that, there's a lot of resource material there. A lot of great YouTube videos and interviews with great people online around these issues, and obviously watch those. I
Mm-hmm.
think look at Dr. Carl Friston's work, Friston. He's been interviewed a lot online. Watch some of those interviews and just start to get a feel of this new evolutionary AI that's coming in, and then kind of trust that this is the natural unfolding of it. Of evolution on this planet. We developed these beautiful brains in the human, and now these beautiful brains have figured out how to build a really big digital brain that could help it. And so you can start to trust that overall, there's always going to be some problems, but overall, the arc of evolution is pretty positive and pretty strong. So I think, just learn more, educate more, and but also come from a fundamental position of trust. With trust with care, I would call it. In other words, really feel positively about where we're evolving toward, and also pay attention to the possible misuses, how we protect ourselves against that.
Thank you, Dan. That was beautiful notes to end on and very exciting in terms of where we're going and what's ahead. And also to be going with some patience, tolerance, feelings of resilience for the next 20 years, because it sounds like it's going to be a wild ride. Thank you, Dan. It's been so much fun catching up with you again.
Buckle up. It's going to be a wild ride, and I think this is a really fun conversation, Sophie. It's so good to see you again, and talk soon.
Yes, love to. Bye-bye. Thank you, Dan. Thanks again very much to Dan Mapes, founder and president of Verses.AI and founder and director of the Spatial Web Foundation. You can follow Dan on LinkedIn, as well as check out Verses at Verses.AI, VERSES.AI, and spatialwebfoundation.org. Immediate action tip. To prepare and start adapting for an AI-powered future, learn more, educate more, read white papers, watch relevant videos and interviews, and come from a fundamental position of trust. Trust with care. Feel positively about what we are evolving towards while paying attention to possible misuses. If you are interested to find out more about how to nurture a trust-based culture, adopt a more open and flexible mindset, and shift your company's approach to be more human-centric, read or listen to my second book, Empathy Works, The Key to Competitive Advantage in the New Era of Work. If you enjoyed this episode, please like my podcast and write a review wherever you listen. For more information to help navigate this extraordinary period of transformation, I publish regular video updates, post frequently, sharing curated useful articles, research, and information. So follow me on LinkedIn and sign up for my Work in Progress newsletter there. I also have a blog which is available on sophiewade.com and flexcelnetwork.com. Until next time.